All right. So yesterday we talked about arithmetic sequence and series. Today we've got geometric sequence and series. So just a reminder, a sequence is just a list of numbers like this. Series means you're going to add them all together. So we just need to talk about what geometric means. So we're going from 2 to 6, 6 to 18, 18 to 54. So this time it looks like we are multiplying by 3. So times 3 times 3 and so on. Oh my gosh, that looks like 1/3. That's supposed to say, oh my gosh. Get rid of that. Let's do it this way. Times 3 times 3. So geometric means that you are multiplying by the same number every time. Okay, so a series, you want to find the sum of the sequence. So great news, geometric, so much easier than arithmetic. All you need is the formula and you don't have to do anything fancy with it. It looks a little worse, but it's a lot easier. Okay, so here's the formula. So the sum equals a parentheses r to the power of n minus 1 parentheses over r minus 1. Okay, so a, it's your first number. So in this case, it would be 2. R is what you multiply by. So we are multiplying by 3. So in this case, it would be 3. And then n is your number of numbers. In this case, we don't have that yet. So let's do an example. So we want to find the sum of the first 10 numbers. So we take your sum equals a, which is your first number, so 2. Then you do a parenthesis, and then you do r. So r is what you multiply by, so that's 3 to the power of n, which is your number of numbers. So we're trying to find the first 10, so we put a 10 here, minus 1, over r, which is what you multiply by, so 3 minus 1. Okay, so then you put that into your calculator. If you want to type it in like this, make sure you put parentheses around the bottom. So I will go ahead and show you. Maybe. So you can type in 2 parentheses 3 to the power of 10 minus 1 and parentheses divided by parentheses 3 minus 1, or you could just put 2 if you wanted, and you get 59,048. So 59,048. So now some of you are probably thinking, there is no way that that number should be that big. Okay, well, let's try it. So our first number was 2. We multiplied it by 3, we get 6. Multiply that by 3, you get 18. Multiply that by 3, you get 54. Okay, so right now we're on our fourth number. If I multiply that by 3, here's our fifth number, sixth number, seventh number, eighth number, ninth number, 10th number. So our 10th number is 39,000. So yes, this makes sense. When you're doing multiplication, it gets really, really big, really fast, and that's because it's exponential. Okay, the last example. Find the sum of the first 100 numbers. So we have 99, 33, 11. So you should already be saying, okay, it's not going up, it's going down. And this is the same as when you were writing your recursive formula. You're always multiplying, you're never dividing. So what can I multiply 99 by to get 33? Well, you're probably thinking, well, I can divide these by 3. So dividing by 3 is the same as multiplying by 1/3. So you're multiplying by 1/3. Okay, and then we're going to do the same thing. So you take your first number. First number is 99. Take what you're multiplying by, which is 1/3, to the power of however many numbers, so 100 minus 1, over r, which is what you multiply by. We're multiplying by 1/3, and then minus 1. So now here, if you want to put it in your calculator and you don't know how to do the fraction thing, you actually have to put parentheses here. And let me think. Here you don't actually need them. Sorry. Okay, so when you type that one in, you should get. I actually really suggest typing these into your calculator to make sure you get the same thing as me. One, to make sure I'm doing it right, which I probably am, but what do I know? So 1/3 the power of 100 minus 1. You should get 148.5. So now you're probably like, the first 100 terms, it only adds to that. Well, if I take 99 times 1/3, you get 33. And then if I take that times 1/3, I get 11. And then I get 3.66, 1.2, 0.47. So even if I do this 100 times, I mean, look at how small that number is getting. This e just means times 10 to the -4th. So all of these numbers are so, so small that even when you do add them, you get a very small number. And that's all we've got for geometric series and sequences.